All right, hello everybody, this is Ms. Piekarski. We're going over the Unit 11 review. You might want to make sure you watch this before the test on Monday. Okay, so first problem, the first 5 problems you're all going to use the same information for. So you have a particle that moves so that its position at t seconds such that, so your t values are between 0 and 4 seconds, and these are your formulas. So for your x, you have 1/2 times t minus 1. For y, you have 2 times t squared minus 1. Okay, so the first question is which equation shows y in terms of x? So we want y to be by itself. If you notice, all your answer choices have y by itself, and we want to get rid of the t. So we want to eliminate our t value. Because we want y by itself, we want to take the x formula and solve for t. Okay, so we take our x formula right here. First, we want to add 1 to both sides to get rid of this negative 1. And then we're going to multiply both sides by 2 to get rid of this 1/2. When we do that, we get t equals 2 times x plus 2. Okay, so now we know what t equals. And in terms of x, we're going to plug this into the y equation. Notice the y equation, you have a t squared here. So all we're going to do is plug that into the y equation, and instead of having a t, we're going to put this 2x plus 2 here. All right. Now at this point, we need to we need to FOIL or use the box method to go ahead and multiply the factors out. 2x plus 2 times 2x plus 2, because you're squaring here. And I like the box method, so I'm going to do the box method. So I have 2x and then a positive 2, 2x and positive 2. My first box, I'm multiplying the 2x times 2x, and I get 4x squared. For this box, I get 2x times 2 gives me 4x. Here, for this box, I have 2 times 2x, and I get 4x. And then the last box, I multiply 2 by 2, and I get 4. Now I need to combine like terms. So 4 times x squared is the only term like that. This 2 is coming from this 2 right here. So I'll show you in a little bit. Okay. After I show you the rest of the combined like terms. Okay, so 4x plus 4x gives you 8x, and then plus 4 here. So the binomial is expanded to be this. You still have to plug it into your y equation, so that's why you have the 2 here and the negative 1 here. Then you want to go ahead and distribute the 2 through everything that's in parentheses, multiply everything by 2, and you get that, and then you have the minus 1 at the very end. Combine like terms, you get 8, and minus 1 gives you a 7, or a positive 7 at the end, and in that case, the correct answer is A. All right, next 2 questions, okay? We really haven't gone over the domain and the range for these functions yet, but we've gone over what domain and range is several times in this class, and hopefully you remember how to do the notation like this with the brackets. So we want to know what is the domain for the function y of x, and then what is the range for y of x. Well, if you just graph the function, the equation that you got here, if we just graph this, it's going to keep on going forever. But remember, you have a limit on your t value. T can only be, whoops, that is really, really big. Let me make that smaller. T can only be from 0 to 4. Okay? So that is going to limit my x and my y as well. Because t can only be from 0 to 4, I want to go ahead and graph it as a parametric function, and on my window, or when I enter the formula in the equation in the calculator, I do go ahead and have a minimum of 0 and a maximum for 4 for my t value. And this is what I get. And I need to know what are these points that I put, these red dots. I want to know the coordinates. So I look on my table in my calculator, and this coordinate is at -1 and -1. So when t equals 0, I get -1 and -1. And when t equals 4, I get 1 and 31. Okay, so now I need to do my domain. Well, domain is all possible x values. So my first x value is going to be -1 here, or my minimum x value is going to be -1, and my maximum is going to be +1. So for my domain, I'm going to be, correct answer is B, -1 to +1. Now for the range, I want all possible y values. Well, my minimum y value is -1, and my positive y value is 31. So for the range, the correct answer would be C. Now notice I have two questions here, but the answer choices are exactly the same for both questions. Okay, so if you forget which one is the domain and which one is the range, if you switch these, they will be wrong. All right, so be careful. Make sure you remember that domain is all possible x values and range is all possible y values. And you also need to remember that your t is going to limit, or it's going to tell you where the graph starts and where it stops. All right, number 4, which table represents the position of the particle? Well, if you've already graphed it, just pull up your table and look at your values. Notice I don't even have when t is 0 listed, and all of these start with t is 0. Let me see if I can still answer find the correct choice. Well, at 4 should be 1 and 31. If you go to 4, 1 and 31 here, that's good. This one's wrong. So B is out. 4 should be 1 and 31. That one's out. And then D is 1 and 31, so that one's good. All right, now let's check some of the other values. For 3, should have 0.5 and 17. 0.5 and 17, that one's good. Over here, 0.5 and 11. A is out, so the correct answer is D. And if I'm not sure, I'll go ahead and look at the rest of the table values, and lo and behold, the rest of them are correct. All right, moving on. Which graph represents the position of the particle? Well, we've already graphed it, so we can just look at the graph and then compare them. It's definitely not A, definitely not B or D, so the correct answer would be C. Okay. Number 7, suppose the position of a particle is given by the following. You have x equals t and y equals 2 times t squared minus 1 times t plus b, and b is some random number, and right now I don't know what the number is. And t needs to be between 0 and 4. If the position of the particle when t equals 0 is 0 and 3, then what is the value of b? Okay, some of you might say, Ms. Pye, we've never done this before. Well, think back to Algebra 1. You have solved for when you had slope-intercept form and you had to find a slope or an intercept. Okay, you've done this type of equation tons and tons of times. So let's go over it really quickly. So right now, x equals t and t equals 0. By dealing with this equation, it's not going to help me at all to find b, since b is in the y equation. So I'm only going to deal with the y equation. I really don't need this at all. Okay. So in the y equation, I'm going to plug in what I know and solve for what I don't know. So I know that when t is 0, my y is going to be 3. So I'm going to take my y equation and I'm going to plug in what I know. I'm going to plug in a 3 for y, and I'm going to plug in a 0 for all of my t's. Okay? And now that I've plugged what I know into the equations, all I have left to find is b. Well, go ahead and simplify this, and you get 3 equals -1 times b. Okay, so this thing here just reduces to -1, and this here just reduces to b. I'm going to get rid of the -1 by dividing both sides by -1. So 3 divided by -1 is just -3. So my final answer is B, -3. Okay. All right, a ball is thrown at an angle of theta degrees above the horizontal at a speed of 35 feet per second. We need to remember it's in feet, not meters. So feet per second from a height of 5 feet above the ground. So my initial height is 5 feet above the ground. Express the position of the ball using a set of parametric equations. All right, so first let's deal with our x formula. It should be x equals, our magnitude is 35, so 35 times cosine theta times t. So make sure your x has your cosine formula. Notice for b, I have x has the sine formula. I don't want that. And I don't want this one because it has sine here. And look, if you notice, x still has cosine here, but it has a whole bunch of extra stuff. This effect on gravity is not going to affect your horizontal values. It's going to affect your y values, your vertical values. Okay, so just by looking at my x formula, I was able to eliminate all these others, and the correct answer is A. Okay. Moving on. All right, an object is thrown off a cliff 200 meters high with an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. All right, so we're dealing with meters here. Notice we have meters per second is our velocity, and the cliff is 200 meters high. How long is the ball in the air? So I want to know when my y value is 0, and I need to know the time when y is 0. So I'm going to deal with my y formula. Let's make sure you set up the equation correctly. My velocity is 20 meters per second times sine of 30 degrees, because that's my angle, times t. And then notice I'm using 4.9 here because it's in meters per second instead of feet per second. T squared plus my initial height of 200 feet. All right. I need to set the equation, equal to 0, and then because I have an initial height here, I'm going to use my quadratic equation, and make sure you are very, very careful about plugging this into your calculator. Okay, your numerator, the whole numerator, needs to be in parentheses. Notice I have parentheses out here and here. Notice that here I have this whole b value in parentheses. I've had a lot of students that either they don't put the parentheses here, and so all they do is square the sine of 30 degrees, or they don't include sine 30 degrees as the b value here. Okay, watch that very carefully. Watch your negative sign here. Don't forget to include it. Okay, and all I'm doing is plugging everything in the calculator. Okay, make sure you have all the right parentheses. If you're not getting your answer that's up here, go back and look at all your parentheses. Make sure you get them done right. If you put them in the calculator correctly, then you'll get t equals 7.49 seconds. Okay, so the correct answer would be D. All right, next question. A set of parametric equations that describes the position of a football thrown by an NFL quarterback as a function of time is. So they give us the formula. Which of the following statements is false? Okay, a baseball is released at 6 feet above the ground. Well, your initial height is right here. So that tells me that this answer is correct. The ball is thrown at a 30-degree angle above the horizontal. So notice that you have 38 degrees here and here. So that one is also true. The ball is thrown at a velocity of 100 feet per second. And I know that my velocity is here is 100, but realize I don't know if this is in feet per minute or sorry, I don't know if this is feet per second or meters per second, so I'm not 100% sure about C. Let's look at D. The acceleration due to gravity is 16 feet per second squared. Okay, so let's look at this. If this is in feet, then it would be 16 or negative 16 here, but notice in your formula, you're not squaring 16, okay? If it says feet per second squared, then that is false, okay? It's just multiplied by 16. Did I say 15? It should be 16. It should not, t is squared, not your 16. Are we good there? So for C, it would be fine, but definitely D is definitely wrong. Now realize you're going to have lots of different versions of the test, so some of you I might change up the numbers here or here or here, okay? So just because in this example this was the wrong, or this was the false statement does not mean that on your test it's also going to be false, okay? So keep an eye on that. All right, we are almost done. All right, so use the following information to answer the last 3 questions. Suppose Arnold hit a golf ball with an initial velocity of 150 feet per second at an angle of 45 degrees above the horizontal. Gee, this is probably seems really, really familiar to you guys. And I want to know what is the flight time of the golf ball. Okay, so because I'm dealing with the flight time, my y is going to be 0, so I'm just dealing with my y equation. Make sure you set it up correctly. It's feet per second, so I'm using 16 here instead of 4.9. And let me see, I'm going to move this up so that I can see all the answers on the bottom. Hold on. Wow, there's a lot of work to do for this one. All right, so once we go through all the work, I'll move this stuff so we can figure out what the correct answer is. All right, sorry. All right, so what are we doing? Oh, we're setting the y equation equal to 0, solving for t. Let's see. What am I missing? Oh, he hit a golf ball. Okay, sorry. For some reason, I was back on the football project or problem. All right, so if he's hitting a golf ball, the golf ball's initial height is 0. So we don't have a plus any type of measurement here. So we just set this equal to 0 and solve for t. Because I only have 2 terms, and but this term and this term have a t in it, I can factor out one of the t's, and I get this equation. Now, because of that, I know that, let's see, what do I know? I know that t can equal 0, but it can also, so one of my factors is going to just give me t equals 0. The other factor, I'm setting this whole thing equal to 0 and solving for t, okay? So one thing that will be the easiest thing to do would take this negative 16 times t and adding 16 times t to get rid of this here. So what happens is I get 16 plus t on the left side, and now on the right side, I just have this 150 times sine 45. Well, I want t by itself, so I'm going to divide by 16 on both sides of the equation, and that gives me t equals 150 times sine 45 divided by 16. We've done this a ton of times, guys. Just plug it in. Make sure your calculator is in degree mode before you plug that in. Okay, and then the t value that we finally get is, let's see, 63 seconds. And look, I don't even have to cover up the other 2 answer choices, so that my answer is B there. Now that I know that the flight time is 6.63 seconds, I can go on to the next question. Suppose that Arnold, okay, next question is, what is the maximum height of the golf ball? So same scenario, I have to use my t value from the previous answer to find the height of the golf ball. So I'm going to take my y value. Y is going to give me the maximum height. I'm taking the y equation, but for t, I'm going to use my value that I had last time, but it's going to be divided by 2. Don't forget to divide your flight time by 2 for your maximum height. And I just plug it into the calculator, and I get my answer is 175.58 feet, so my answer is D. Okay, final question, what is the horizontal distance of the golf ball that the golf ball travels? This time I'm using my X formula, and I'm plugging in my flight time that I got from question number 10, and I just plug in 6.63. Well, I'll use the exact answer in my calculator, and I plug it in, and I get 703 feet and 1.25 feet. So there we go. All right, so guys, this multiple choice test is only 12 questions long. So the test is going to be, or each question is going to be worth a little bit more. Hopefully you'll be really versed in the process. It won't be too hard for you to find your flight time and horizontal distance, vertical distance, and all that fun stuff. We've gone over it all week last week. Good luck on the test on Monday. Oh, you know what? go ahead and fill out a 3x5 card when you're taking these notes or when you're going over this. You can use your 3x5 card on the test. All right, bye.